Welcome to the Explainer. Today we're going to talk about something tiny, a 512-byte file that for decades was maybe the single most important piece of code on your PC. I mean, it was the gatekeeper, the very first word your computer read, the key that started everything. Let's dive into the master boot record. Okay, let's start with a quick question. You hit the power button on your computer and it just boots up, right? But have you ever stopped to think about what's actually happening? In that huge sea of data on your hard drive, how does your computer know where to even start looking for your operating system? What's the very first thing it reads? Well, the answer to that little riddle is a tiny and honestly an unsung hero of the boot process. It's called the master boot record, or MBR for short. And for years, this was the absolute, non-negotiable starting point for pretty much every PC out there. So the easiest way to think about the MBR is to picture it as a gatekeeper. It's this special little boot sector living at the very beginning of your disk. And I mean the very first physical spot. This location is so important, so critical, that your computer's BIOS, its basic firmware, is hard-coded to look right there and only there every single time you power it on. No exceptions. All right, so if this thing is the gatekeeper, what's actually inside it? You're going to be pretty amazed by how much work gets done in such a tiny, tiny amount of space. And when I say tiny, I'm not kidding. The entire MBR is just 512 bytes. To put that in perspective, that's smaller than the text in a short email. It's almost nothing. But somehow, packed into that tiny little package is everything your computer needs to get the whole boot process started. Okay, so those 512 bytes aren't just one big blob. They're broken down very precisely into three key parts. You've got the bootstrap code, the partition table, and the boot signature. Each one has a super specific job, and if your computer is going to start up, all three of them have to play their part perfectly. The biggest chunk of this, about 446 bytes, is something called the bootstrap code. You can just think of it as a tiny little program, and its one and only mission in life is to find the active partition on your drive, the one where Windows or Linux actually lives, and then pass the baton. That's it. That's its whole job. All right, next up is the partition table. It's just 64 bytes, and it's basically a map of your hard drive. It lays out where your different partitions are, up to 4 of them. It tells that bootstrap code we just talked about, where each one starts, what kind of partition it is, and, most importantly, which one is the active one that it needs to boot from. And then we have the last 2 bytes, and this part is actually my favorite. It holds what's called a magic number, and it basically acts like a secret handshake. It's how the BIOS confirms, yep, I've found a real bootable disk, and not just some random garbage data. The secret handshake, it's called the boot signature. And it is always, 100% of the time, the hexadecimal value 0x55AA. If the BIOS looks at the end of that 512-byte block and doesn't see that exact signature, it just stops dead. That's when you get those frustrating errors like missing operating system. So, let's recap. We've got the instructions, the map, and the secret handshake. Now, let's put it all together and see how this perfect little dance brings your computer to life. The whole sequence is actually pretty elegant when you think about it. The BIOS finds the MBR and loads it into memory. It checks for that 0x55AA signature, and if everything looks good, it hands over control. Then the MBR's little program takes over, reads its own map to find the active partition, and then it loads that partition's own boot record. It's like a chain of trust, right? The BIOS trusts the MBR, and the MBR trusts the next guy in line to keep the process going. And you know what? For decades, this system was basically perfect. It was simple, super reliable, it just worked. But as you can probably guess, technology kept marching on, and pretty soon the MBR's beautiful, simple design started to show some cracks. It started hitting some very, very hard walls. So problem number 1, that partition table we talked about, it only had space for 4 main partitions. Back in the day, 4 was more than enough for anyone. But for modern computers, that became a real limitation. People had to come up with these clunky workarounds like something called extended partitions just to get more. But here's the real killer. The MBR used a 32-bit system for addresses. What that means in simple terms is that it just couldn't handle drives bigger than 2 terabytes. That was the mathematical limit. So as hard drives got bigger and bigger, anything past that 2 terabyte mark was just invisible to the MBR. It simply couldn't see it. So you've got the 4 partition limit and this 2 terabyte wall. Suddenly, the MBR wasn't this elegant solution anymore. It was a bottleneck. It was holding everything back. It was clear that it was time for something totally new, something built for the modern world of massive storage. And its successor didn't just put a Band-Aid on the MBR. Nope. It completely rethought the whole idea of disk partitioning from scratch. And that brings us to the GUID Partition Table, or GPT. This is the new standard that you'll find on modern computers with UEFI firmware, which is the replacement for that old BIOS system. And GPT was designed for one purpose, to completely shatter all of the MBR's limits. And man, what an upgrade. GPT can handle disk sizes so big, we have to measure them in zettabytes. That's a trillion gigabytes, which is just mind-boggling. It lets you have 128 partitions right out of the box, no messing workarounds, and, maybe most importantly, it adds all these safety features the MBR never even dreamed of, like keeping a backup of the partition table and using checks to make sure your data is safe and not corrupted. So yeah, GPT is the standard now, for sure. But you really can't overstate the MBR's legacy. That brilliant, simple 512-byte design was the cornerstone of PC computing for more than 3 decades. It was a true masterpiece of efficiency, and it really did lay the groundwork for everything that came after it. And that kind of leaves us with a final question to chew on, right? For decades, the MBR was this essential, totally invisible part of every single computer. Now, it's basically a museum piece. It really makes you wonder, what piece of tech that we use every single day, that we can't imagine living without, is the next MBR? What's the next brilliant solution that's just waiting for the future to come along and make it obsolete?